with Wika for the power and water business. And before I start, I'd really like to thank our channel partner, Wika's channel partner, FLW Southeast, for hosting this webinar. And I appreciate you guys for logging in. In the next 45 minutes or so, I'm going to give an overview in terms of products and applications that Wika offers for the power generation industry. And it's a relatively small group. So feel free to ask me if you have any questions at any point of time. Although towards the back end of the presentation, we will have more than a few minutes to go over any Q&A as well. Uh, so I'm going to go ahead and get started. The slide essentially shows a graph which talks about different sources of power generation within the United States. And this is tracking the history. This is information from IEA, which is the International Energy Agency, and also US Department of Energy to compile this information on an annual basis. And this is dated till 2019. But it's very good depiction of the current power situation at a global level, and in a lot of cases it also mirrors what is seen in the United States. So one thing you'll notice is coal is relatively flattening out, and it is probably expected to go down further. Natural gas has been increasing in terms of usage for power generation. Nuclear is relatively flat, and of course the renewables, wind and solar power, and those type of renewable sources of electricity are going up. Wika essentially has products and services that we offer that plays into all of these different subsegments. So irrespective of whether it is going to be a coal-fired power plant or a combined cycle, we also have nuclear qualified products. So they can be used in the containment area or the nuclear zone, if you would. We have strong references for solar thermal as well. Energy from waste, trash burners or incinerator type of power plants, as well as biomass power plants, as more and more power utilities across the nation seek to get renewables label or a green label. We also have good installed base in terms of different hydropower plants throughout the country. Part of Wika's services portfolio is something that we refer to as FAST audit, which really stands for Factory Audit Service Team. It's really an instrument survey that is provided as a service to our customers. And we've done a lot of these plant instrument surveys throughout the country, including for power. And I've myself led some of those instrument surveys. And so we have a lot of data in terms of the type of instruments that are provided, are being used in the plants, and what type of failures occur, or what are the best practices in terms of applications, the various applications, and which devices should be used. And specifically, being the leading manufacturer of gauges, we have extensive data related to gauges, different types of gauges that get used in a power plant, apart from the different applications and equipment that they are used in conjunction with. A quick top line overview in terms of some of the key products that we provide and some of the applications that we'll do, and I'll have more information specifically related to the applications in the coming slides. Wika's core competence is mechanical products. We do have quite a few electronic products, and I'll share some more information related to that as well. But specifically on primary flow elements, which is differential pressure flow technology, we provide instruments for monitoring flow of steam, condensate, and especially at the higher temperatures and pressures. We have primary flow elements that do a really super job, that are calibrated. They go through a special calibration process and are kind of seen as the industry standard. And we have strong references related to each of these. Uh, so Wika is known as a gauge company, but part of what I'm going to cover in the presentation is a lot of the other products that we have in our portfolio that lend themselves very well to a lot of different applications in different sections of the power plant. So we have pressure gauges and temperature gauges, of course, but also temperature sensors and transmitters, RTDs, thermocouples, thermowells, and a bulk of what we supply really relates to monitoring pressure and temperature in the heat recovery steam generator or boiler, if you will, but also the gas and steam turbine areas. Those are kind of the major areas where some of the products that we supply get used. Uh, as far as the company goes, part of what brings expertise and things that Wika brings to the table really uh, relates to the fact that we are a global company, but we do have local manufacturing in different regions across the world. So irrespective of where the project is happening, we have the ability to support that, whether it is in after sales support or aftermarket spare parts, etc. A very broad product portfolio. And as I go through the presentation, I'll cover some of these key products that we provide. Like I mentioned earlier, the core competence is with mechanical portfolio, but we do have quite a few electronic products as well that are of very high quality. We are about the only full line instrument supplier that can not only provide instruments for the traditional or conventional type of power plants, fossil fuel or renewables, but also the nuclear power plants. And this is irrespective of whether you're talking about the traditional large scale reactor type of power plants or some of the newer technologies that are coming into play, like the small modular reactor, etc. So we have nuclear qualified instruments and we have very strong references related to some of the major projects, and having worked with some of the major package vendors and equipment suppliers throughout the plant. Wika is also one of the very few companies that, apart from power generation, also has devices that are used on the transmission and distribution side of power. And I'm really referring to SF6 monitoring and SF6 handling equipment that's typically used around the high voltage circuit breakers and that type of electrical equipment. So keep in mind, just touching upon some of the application areas. If any of you guys are interested in a deep dive type of presentation on a specific technology, we can have a separate session scheduled for that as well. Just let me know. Uh, Primary flow components, primary flow elements. Like I said, this is really driven by differential pressure flow technology, which is very commonly used, irrespective of the fact that over the last several years, there have been a lot of electronic flow technologies that have come into play, but there are specifically when it comes to steam and even in a lot of areas related to condensate flow measurement, DP flow technology is still the preferred technology, and there are multiple reasons as I talk to end users related to that. From an end user point of view, the fact that they can do a lot of maintenance, and these are technologies in some cases because of the fact that these DP flow is directly linked to operation and validation and certification of steam turbines and overall plant efficiency. In a lot of those areas, it's dictated by different ASME standards or ASME PTC, as they call it, performance test codes. But even apart from that, the fact that a DP transmitter can be isolated by a manifold and any kind of maintenance can be done on that particular line without pulling the steam line offline. That makes a lot of difference for a lot of these plant operators and maintenance folks from an end user side. Uh, Bulk of the applications that we really do relate to ventures and flow nozzles, but we do supply orifice assemblies, orifice plates that are again used in a lot of different sections of the plant. I've seen these being used even on the water treatment side. Sometimes it's just the application is very basic in order to generate a DP and have a tap line to take a sampling of different water streams or steam analysis. Uh, we also provide meter run assemblies. So these are normally used in pipeline applications, but with every combined cycle plant and in almost a lot of the coal fired power plants as well. They have a backup source through using natural gas, and that's where essentially they have to do like a custody transfer on natural gas. So they have like a custody transfer metering system, and irrespective of what flow technology they are using, whether it's orifice assemblies with DP transmitter or I have also seen ultrasonic flow meters or Coriolis flow meters that are being used. They still use meter runs to get uh, a good flow profile that can be monitored using through some of those flow metering technologies. So we do a good amount of work with some of these skid suppliers that provide the custody transfer metering systems through the meter runs that we provide. Uh, we also provide pitot tubes. So in a lot of the applications, the customers, like especially on gases, air, that is used in different parts of the plant, but in a lot of the cases related to combustion and being able to monitor the combustion and efficiency of combustion. Pitot tubes are still pretty commonly used, but bulk of the work that we do really relates to ventures and flow nozzles, and a lot of it really has to do with uh, hot water like boiler feed water, or even the steam, whether it is high pressure or medium pressure, or like intermediate pressure, or even low pressure in some cases, and also condensate removal. Makeup water and cooling water, those are some areas where some of the customers were using, have been using DP flow technology with orifice assemblies or orifice plates, and in some cases, they are switching over to some of the electronic flow technologies. So Venturi tubes, by far, like I said, Venturi tubes and flow nozzles are bulk of what we supply into the power market, and these are all designed and built in accordance with the ASME PTC 19.5 and other relevant ASME standards. A lot of it really relates to the projects. On some of the international projects, we see more of the ISO standards being applied. So we have our engineering folks that are trained to be able to size flow elements based on the flow characteristic data that is provided by the engineering companies or contractors, and be able to provide the design calculations. We also have welders that are trained and have to go through an annual certification process each year based on the ASME certification that they have to carry. The certification is also for our machine shop, where all of this welding and machining happens on these mechanical assemblies. So we have a lot of experience both in terms of small as well as large line sizes. In some of the locations, we work very closely with some third-party calibration labs, although in one of the facilities, we do have our own internal calibration lab as well that can provide. So we also invite customers to visit some of these labs depending on where the project is happening, etc. We also do third-party calibration. So there are a lot of times where some customers reach out to us about recalibration on existing flow elements that they might be using, and we provide that as a service too. Flow nozzles are another, you know, piece of primary flow elements that we provide, and these are specifically designed in accordance with ASME PTC 6. That's the specific standard which dictates how the flow nozzle has to be engineered, calibrated, and even to the extent of the machining and the welding that takes that happens on these flow elements. And these are used to validate the steam turbines. So, a lot of the Hersig manufacturers as well as the steam turbine manufacturers have specific requirements relating to the flow nozzles that they want to use in conjunction with their equipment. And we have a good knowledge and experience in terms of building these flow nozzles to the specific requirements. Over the last few years, we've supplied over 500 of these across Americas. One of the things that we are also seeing, and this is also being dictated by the renewable energy standards or renewable standards in different states across the country. Uh, there is preference for renewable power to be on the grid over, say, conventional or non-renewable power. So, for example, if there is a coal power plant or a combined cycle power plant, they have to run the plant at whatever efficiency or whatever rating or megawatt capacity that is dictated by the grid operator, because they can only put a certain amount of electric power on a specific day on the grid. If they do not meet that requirement, there is very heavy fines that are imposed by the grid operator. And what that does is, for a lot of these plants, they are running at uh, much lower capacity than what their plant has been designed and rated for, which basically means that you could have a combined cycle power plant that was rated for 500 megawatts, but because of the renewable power that is expected to be on the grid that day from solar PV farms or wind farms, they might have to run the plant at 300 or 350 megawatts. And what that does is it imposes a lot of thermal stress on all of their high pressure mechanical equipment like the Hersigs, the heat recovery steam generators, the boilers, and a lot of the feed water heaters or condensers and that type of equipment, which causes a lot of uh, corrosion and other kind of challenges for them in terms of how they do their plant maintenance. And because of that, it is dictating a lot of the equipment suppliers, the heavy equipment suppliers that provide the Hersigs or boilers and that type of equipment, to look at using non-traditional or specialty type of metals or alloys. So I'm not really talking of Hastelloy or Monel or titanium type of materials being used by the Hersig manufacturers, but definitely chrome moly steel. We've also heard of HR91 and different types of materials based on ASME or ASTM codes. So we have a good amount of experience in terms of the mechanical, welding, machining, and other mechanical work that is required with those type of specialty alloys and materials. So these are different grades of stainless steel beyond just SS316 that most people would commonly use. And we have our plant shop guys have a lot of experience and training and working with a lot of these non-standard metals to build a good quality product in terms of the flow tubes or venturies or flow nozzles. And we are big, continuing to get more and more requests with these type of specialty type of metals, and we do a lot of work with this. So we have suppliers that we have developed and work closely that can provide this to us in a reasonable amount of time as well. So this is kind of a quick snapshot, kind of shows it's a you know a sample from a PNID diagram that shows the steam loop in a typical thermal based power plant, showing the feed water pumps and the turbines and essentially the steam loop. And you have the orifice flange assemblies primarily monitoring steam. You have the flow nozzles around the feed water pumps. There are also some other areas where compact orifice or standalone orifice assemblies are used as well. So that's like a typical configuration. Uh, One thing that I will also mention is Wika, apart from providing the flow elements, we also have the ability to assemble a complete unit. So it's not just a primary flow element, but also a manifold and or a DP transmitter. And in some cases, we have also provided orifice assemblies with differential pressure gauge, because in some plants, we've actually received requests where they not only want the ability to install a differential pressure gauge, but also a DP transmitter. So we have the ability to provide all the mechanical fixtures related to that, and or provide it as a complete package. So we do a fair amount of work with different instrument manufacturers or transmitter manufacturers as well. Uh, Moving on to level, so that was as far as our flow product portfolio goes. Moving on to level, again, like I said, our core competency is in mechanical level. We do have a few electronic products as well, and this is an area that we'll touch upon. So our core competence, we provide the mechanical level assemblies, the bypass chambers, or the magnetic level indicators. Uh, but we also run into areas of application where they want to use like a mechanical level switch, which is based on like a read chain technology. And sometimes customers want like a magnetic level indicator with like a read chain type of transmitter. So these are not as high accuracy as, say, a guided wave radar, but there are also benefits in terms of the value that it provides based on cost competitiveness, etc. And not all the applications necessarily require that high accuracy. So this is again a float based type of technology, and we actually have another product that we offer again based on float type of technology. So it's again a magnetostrictive transmitter, which can get pretty close in terms of accuracy, etc., with uh, guided wave radar, although it may not be as close. So there are applications where we've provided, and one simple application that I can think of is like a silica water wash storage tank. So those are, and also like fuel tanks, backup fuel storage tanks. So these are some areas where, a very high accuracy device may or may not be needed. And plus, if a mechanical assembly is required for an operator to get some kind of indication from a good distance while he's walking the plant, then it's a good type of instrument to be used. Uh, we've done quite a few of these where in a lot of the plants, they water wash the steam turbines with water every once in a while, depending on what their standardized procedures are. And every time they're washing the steam turbines, there's a lot of silica that has accumulated on the turbine blades that gets into the water. So they cannot just get rid of that water after washing the steam turbines, etc. So they store it in a storage tank before it can be sent for water treatment. And that's an area where they've used some of these magnetostrictive transmitters or read chain type of transmitters with the magnetic level indicators. We also run into applications where the customer absolutely wants a guided wave radar, and we work with a couple of different guided wave radar manufacturers as well, where we will, depending on what the customer preference is, we'll package it together and provide it. FLW, for example, carries the line of a specific manufacturer. So we do a fair amount of work through those guys as well, where it can be provided as a complete package. Uh, Specifically on some of the uh, systems in power plants, whether it's the uh, condenser or hot well, feed water systems, preheaters. A lot of the plants have triple redundant configurations in place, that kind of system where they need to have at least three measuring technologies or three measurements to happen on a single point, and at least two out of the three readings have to match before the DCS can take any control action. So we have the ability to provide the mechanical bypass chambers and or the magnetic level indicators as well that would be used in conjunction. And almost all of the times, these are going to be provided or will be using some kind of electronic level measurement technology as well, like a guided wave radar or sometimes a magnetostrictive transmitter. So like I said, we can either do it completely in-house or we work with other third-party manufacturers to provide a complete level solution to the customer. So I mentioned earlier about some of the applications that we do, cooling towers, sumps. We also have mechanical level switches that we can provide. And some cases, continuous level measurement is not really of interest. It's really point level measurement or like a switch functionality that is needed. So we have, products that we can provide for those kind of applications as well. But these are some of the common areas in terms of level measurement where we provide our products. Moving on to temperature, like I mentioned earlier, we not only provide temperature gauges, but we also have the ability to provide all different types of temperature assemblies, RTDs, thermocouples, thermowells, and we not only provide the standalone simple, simple RTD that would be used, say, in a cooling tower. We also have the specialty type of tube skin thermocouples that tend to be used for boiler tube monitoring. So we do a good amount of work with the Hersig manufacturers, uh, the Nutter Ericssons and Vogue Power, etc. But we also do a good amount of work with contractors or end users when they are doing their turnarounds, because there are occasions when they need to replace some of these thermocouples. So we not only provide the thermocouples, but we also have our people in-house that are essentially service engineers that can go on site and work with the customers in terms of installation and commissioning of some of these boiler tube probes. Like I mentioned earlier, we also have strong references related to solar thermal as well as hydropower as well that we can provide. So we have done a lot of work with some of the major contractors and EPCs related to those type of projects. And this is just a quick snapshot of some of the different areas where we've provided temperature probes, different applications relating to the water steam system, lube oil temperatures, cooling towers, also the heat transfer fluid on the solar thermal type of power plants. Bulk of these really are in the southwest part of the United States and different parts of the Middle East and Southern Europe, like Spain, for example. So this is just a little bit more detail on the tube skin type of thermocouples that we provide for boiler tube monitoring. We also have specialty sensors that we have developed for a fast response time. So there are areas in a power plant where they tend to monitor the temperature, and they want to make sure that the temperature has reached a certain point, and once the temperature reaches a specific point, they want to open a steam valve as quickly as they can. So we have what we refer to as an exposed insert, which is essentially it has a thermocouple, but at the end of it, there is a small piece of the RTD element is exposed. So sorry, the thermocouple is exposed, which allows for a much faster response time than what you would typically get. So in a standard thermocouple, the response time is going to be more like close to 7 seconds or something like that. So this is essentially showing like a temperature sensor. Excuse me, I need to just drink some water. So the preheater area and the inlet for the main steam on the turbines, they have applications where the temperature sensors are again used in a triple redundant configuration. So, they want to, from an operator point of view, the DCS is monitoring and making sure that at least 2 out of the 3 readings match before they take the control action. But specifically, they have the high pressure valves And what they want to do is they want to make sure that the temperature has reached a certain point before they open the high pressure valve, but they also want to do not lose any time. So, the absolute instant that the temperature reaches the specific setting, they make sure that they open the main steam valve. So moving on to mechanical pressure, like I said, Wika is a company that is known for all right. Thank you. Um, one thing that we have seen is, there are a lot of customers that use power pressure transmitters, but almost always on a lot of those points, they're also using gauges. And a good question would be, if they're already using transmitters, why do they need gauges? But in all the different plants that I've walked through and the different operators and instrument folks that I've talked to, uh, they almost feel that just for about every transmitter there has to be a gauge, or sometimes more number of gauges than even transmitters, because in some areas they don't necessarily run wires back to the control room, but when an operator is there, they absolutely need a sanity check and they want to make sure, and a lot of the times they're not necessarily interested operator to see from, say, maybe a 10 feet distance to what kind of pressure is reading at a specific point, and that's where gauges serve a good purpose. Plus also when they're doing a cold startup, where basically the plant is being started up from scratch during the initial startup or right after a turnaround that they might have had, that's where a gauge plays an invaluable role in terms of the operators being able to do a good job, and a smooth commissioning and startup of the plant. So this is just kind of showing different types of gauges being used on different application areas around the plant, whether it's feed water pump, cooling system, steam turbines, water steam loop. But again, and we have a separate presentation. We get a lot of requests on customers that want to learn more about how gauges get applied, believe it or not, because gauges are almost an oft afterthought for a lot of the plants, but from an operator point of view, they can play an invaluable role. So we get a lot of requests also to come in and talk about gauges and how what is the criteria for selection of gauges, and in terms of application, what's well suited for one application versus the other. So for example, when there's a lot of vibration, we definitely recommend to our customers that they go in for a liquid filled gauge versus just a dry gauge. So we have like a standalone presentation that we do on those type of topics as well. So if any of that is of interest, don't hesitate to let your FLW folks know, and we can definitely arrange to set it up. So I just wanted to quickly share one specific model. This is like the 732, probably the most common gauge that we sell on the bulk of the applications where it gets used relates to filter monitoring, especially on the water treatment, but also on turbine inlet air filter, where they have to monitor the differential pressure and different based on what the capacity is of the turbines, which really decides what the filter capacity is going to be. I have seen gauges as well as transmitters being interchangeably used. So there are some customers that prefer to use gauges. There are some customers that prefer to use DP transmitters, and some customers, they prefer to have both. It really depends on where the installation is and how they're planning to use it. But This is probably the most common DP gauge that we supply in power generation. Again, also in DP monitoring on compressors, condensers, but also for monitoring differential pressure on heat exchanger and some of the cooling circuits. Temperature gauges, like I mentioned earlier, we do, apart from RTD thermocouples, we also offer temperature gauges, or what are commonly known as thermometers. So we have gas actuated thermometers. We also have bimetal thermometers. One thing I also wanted to mention, so you will see different ASME standards being referred to. Wika is one of the very few full line instrument suppliers that has its own people serving on different committees. So ASME B40 was one of the standards that was developed with regards to gauges, and we had our some of our engineers on some of these committees. So that kind of gives us an insight in terms of what these standards are referring to and how best to design and develop the product to, so that from a customer point of view it meets the most stringent requirements. So this is again basically showing one of our newer bimetal thermometers with liquid dampening that is designed for high vibration. And one thing that you will notice is that the display or the dial of the gauge can be rotated to a certain degree. So it allows for flexibility in terms of the installation. Uh, this is again in terms of core pressure gauge, the 23350 as well as 232.54. Those are, and I know these part numbers might sound a bit confusing, but you don't have to memorize this because we can work through based on the spec sheet that you guys might have. But those are some of the very common models that we offer with regards to gauges. We also run into a lot of requirements where customer wants a gauge but also wants like a switch output in conjunction with a gauge. And uh, despite, like I said earlier, there are a lot of customers that are using pressure transmitters, and there are also a lot of customers that, apart from using pressure transmitters, want gauges. And a lot of the areas they also want gauges with switches. So we have the ability to provide that as an integrated unit. Specifically in power plants, I've seen a whole bunch of these being used in the water treatment section because there is a good amount of panels or skids in that particular area. So for also lube oil skids, that's another area where we tend to provide a whole bunch of these gauges. Again, we've also run into requests where customers want a gauge, but sometimes they also want a transmitter. And so we have the ability to provide that functionality as well. We also provide standalone pressure switches. Uh, so again, we see a shift towards electronic pressure switches, and I have a slide. I'll talk about that. We offer those as well, but we do offer mechanical pressure switches. So this is our electronic pressure switches. Again, a lot of these, I've seen these more on standalone small skids or panels or standalone systems relating to air tanks or simple applications. But this is it's not you're not really going to getting a relay. It's an electronic pressure switch, but there's like an NPN type of transistor. It's an open collector output that you can get, which gets hooked up to a PLC. Moving on to electronic pressure, apart from electronic pressure switches, we also offer high accuracy, high precision transducers that are used for monitoring pressures related to gas turbines, also steam turbines. And this is actually showing the turbine inlet differential pressure that I was referring to earlier, where I was talking about offering a differential pressure gauge. We also have the ability to offer a high pressure, high accuracy differential pressure transducer if it is needed. A lot of these are used more on research and test stands by different turbine manufacturers, but also in some cases in terms of power plant end users where they might be running their own testing on different plants like pilot plants, etc. Just going through a couple of quick and easy applications. So this is pump monitoring is a very common application in a power plant, and we essentially provide TR58, which is RTD that is customized to be like a bearing temperature RTD. So it keeps track in terms of what the vibration levels are, and it's designed to withstand the high vibration that it'll have to see. So we provide this like with a hockey puck transmitter. On pumps, they also like to monitor the suction pressure, in some cases also the discharge pressure. So we have a couple of pressure transmitters that are small, compact. They don't take up a lot of space. They don't really have a display, but typically in some of these applications, the customers doesn't necessarily need a transmitter with a display. So we have the ability to provide this. It's a relatively very competitively priced unit, also a small footprint. So apart from gauges, we can provide this as well. Some pits are also very common in any type of power plant. And there are different technologies. I've seen different customers use different type of technologies. By far, one of the more common type of solutions that we provide is like a hydrostatic level transducer that can be provided as a standalone unit that they can just drop in a sump. And a lot of these sumps have grates, so they can just slip this in through the grating that they have on the sumps. In some areas where there is a lot of gunk, we also provide like a mechanical chamber that we refer to as a level guard. So just a few things to keep in mind. I mentioned earlier about skids, lube oil skids. This is like an RO skid that's being used in a water treatment section of a power plant. So we have devices, like I mentioned, apart from gauges, we can provide the PSD4 electronic pressure switch, but also apart from A10, we also have like another uh, uh, relatively small compact transducer, which is comparatively priced, called the S20. Some of the very common applications that we do in power plants, both whether it's electronic pressure transmitters or with gauges or DP gauges. Uh, so being a gauge company, one of the things that we also bring to the table is we have like a digital gauge. So it's not a transmitter, it's still a digital pressure gauge, but it has Bluetooth capability. It is also battery powered, so it will not give you a 4 to 20 milliamp, but the Bluetooth allows it for remote configuration, and you can download the information. So the unit also has a small memory chip built into it. So we see a lot of customers use it for remote diagnostics or troubleshooting. In a lot of the power plants, specifically like in coal or hydropower, they use a lot of hydraulic systems. That's where they need to uh, check validate those systems every once in a while. And that's where these type of devices get used. Valve testing is another area. This is also a much higher accuracy. So a lot of the plants also use it like a high precision test gauge, if you will. Uh, we actually supply a couple of these digital gauges. So they're the predecessor to the CPG 1500. That's the most recent one, is CPG 100. And this kind of shows a fresh uh, picture. So we actually have the ability to supply it like a complete test kit with a hand pump and everything. So it simplifies uh, things for the operator when they have to go on site and test a system, a valve or a hydraulic system, or calibrate a pressure transmitter or some kind of other pressure instrument that they might have. This is an application. So like I said, we have a lot of different instruments for different applications across different sub-segments of a power plant. So this is like on a geothermal power plant on a wellhead application. So that's an area where there's steam coming out of the ground. The steam that comes out from the ground is not clean. There's a lot of gunk because there's going to be a lot of sand and mud and dust and other particles as part of that steam. So they actually use a diaphragm seal. And this is actually showing it with a capillary that's hooked up to a CPG 1500. And every once in a while, the operator can go and download the information into his laptop or Android or iPhone. And there's an app that's available. And they can go back to the shop and analyze it for what the readings are, or keep it as part of their record. We also have, so we have the ability to supply a complete pressure loop, pressure instrument loop, if you want to call it that, or a point where we not only supply the pressure gauge or transmitter, but we also supply the 3-valve manifolds and or a manifold if the customer wants to install both a gauge and a transmitter on a single line at a point. We also supply some of the small needle valves, ball valves, double block and bleed, etc. So keep us in mind, and all of these are all accessible. You can buy all of these through FLW, which is our channel partner. Diaphragm seal repair service. So we are also, Wika is also one of the largest diaphragm seal suppliers in the world. But we also do a lot of repair work, not just for diaphragm seals provided by Wika, but also by other third-party manufacturers on anybody's pressure transmitter. So, and there are a lot of times where it has actually saved customer a good amount of money, because it can be a fraction of cost to try and repair or replace a diaphragm seal rather than replace a complete transmitter. So that really summarizes and completes the presentation. I'll leave the floor open to any kind of questions or comments that you have. We do have a website as well that has a lot of information related to this. We keep and maintain a blog as well where we post a lot of information related to this. And you'll also find FLW on the social media, specifically LinkedIn, and they share good amount of information related to the products, services that they have to offer as part of their portfolio for power generation. So thank you for your time and attention, and I'll keep the floor open to any questions or comments that you guys might have.